Bismillahirrahmanirrahim. Hello everyone. This is another ETABS course. In this part, I want to completely design a multi-story steel structure, and also, if there was enough time, we will do some connection design and also some detailing. But first, let me create a model and also apply the gravity loads, earthquake loads, and wind load. This is the typical layout for a 6-story structure. 6-story, and so in the X direction we have 5 bays, each bay has 6 meters, and in the Y direction we have 3 bay, each bay is 5 meters. And the height of the story is 3.2 meter, typical from basement to top, or from ground floor to the top floor. We will use this steel in European code, steel 355, and we will use beam, column, and bracing. For this, we will define a auto IP section. That IP section will consider from 200 to 500, which is this suggested profile can satisfy these requirements. And we will have a slab. This slab is not just for designing, just for the diaphragm, because we will apply the load in that slab, and also that slab can play as a diaphragm. And the last things, we also can calculate the self-load of that slab, but we will not considering the design of that slab in this tutorial. And the applied gravity load as a super dead loading exclude of the self-load 1.5 kilonewtons per square meters, and we also have a live load 2.5 kilonewtons per square meters. With the seismic load, we pick up these two parameters based on the earthquake hazard maps, and this is the system which we applied. This is a concentrically or double system, which R is 5 and CD is 5. You can get this from the AC7, and omega factor is 2.5, and the importing factor is 1. So the wind speed, the wind we will apply a speed of the 80 miles per hour, and the exposure is B, which is located the structure in the urban area. So we will consider the gas factor and other properties in there. So now we're starting for modeling, and we go to ETABS using the latest version of the ETABS 20. Going to new, we're using metric and using European code. Material, also we selecting European material, and still design code. You can use any design code you want, but let me for European code, let me use American code, design code. So we don't have concrete, you can select any of them, it's okay. Okay, now this is the X, which is this direction. So we total have 5 bays, so that 5 bay require 1, 2, 3, 4, 5, and 6 bays, and in the Y is 4 grids, so the X is 6 meters and the Y is 5 meters. So this is the total stories, which is 6 stories, and each story is 3.4 meters, 3.2 meters. Now we can select grid only and say okay. Now we have this is the here is the plan, and now I want to define some materials. So it's already S35 is defined. You can see the properties is this is the weight unit per minutes, and you can come to the here, and you can see the yield strength is 3.5 and minimum tensile strength and other parameters. Okay, and next I want to define auto section. So we don't have here IP section. Let me first import the IP section. It's taking to load. So from here I can select IP, and here is IP section from 200 to 500 or to 600 is okay. So now here I'm gonna call OK, and I add it. So I'm gonna call add new property here, select auto section list, and I can call it auto profile, which is including the brassings, beams, columns, everything, and also secondary. And add. Okay. Now we want to define columns. So I can select all stories. So the column in entire story is same because it's automatic, and the program will determine for us based on a given load a proper profile. I'm selecting auto profile and defining all columns in this direction. Now what we're gonna do is I wanna select this one, and I want to select this one, and just changing the local axis. So I'm going to translate it to 90 degrees. You can see. So I change the location which is equal to my model. So next, I want to define quick drop beams, and selecting again that auto profile and selecting all, so the entire beam is applied. If I go to the 3D, and you can see that structure seems like this. You can see in 3D. Now the next is, let me define some so let me define the brushes. So, and I'm gonna go to this elevation C. So I can select here elevation. Let me go to elevation C and D. So I can go to first. Okay, and it's actually there. It doesn't matter. I can draw in that window. Now again, I comes to here. It's called quick draw column, and now I'm selecting quick draw brass. Here first you will define the properties. You already defined auto profile, and here is the moment release. So mostly we have connected the hinge, so that's paint, and now I want to select V inverted. So V inverted is like this. I want to select one story, so I'm selecting one here, and here. Yeah, now since it's auto, so selecting a very large section, but the program, after we apply load, it will determine as the proper one. So now it's DC, and I'm gonna comes to this one, move to list, and this is B, and I'm gonna back again C, and this is D. We have in D now. Here is D, and one more thing. Again, I'm going to the third elevation. We want to apply one here. D third elevation. I'm going back to elevation 3. Now you can see here is elevation 3 between 3 and between C and D. So I'm going to select this one here, and here. So we applied, and if I go back to 3D model, now you can see that location is defined. We defined a core area with a browsing system. So what we're gonna do is now, and I'm gonna select all studies, and I'm gonna select this one, and you can see the entire beam column in that area is selected. Now it's a 6 meters, so I'm gonna replicate this by 3 meters in a linear in the x direction, which is called 3 meters. Apply, and you can see exactly in the middle of that column. And we can see now we have one extra layer here. So this is correct, and now it is time to define all story. Let me go to all stories and define the slab. But before that, let me go to the section. Here is called slab section, and I'm going to modify this to 150 millimeters using concrete 330. Okay, now I can go to select this rectangular shape, and I'm going to select this one, this node, and this node. So now you can see the entire slab is added. So next, what we're gonna do is I'm gonna draw a opening. So I can select the same, but this time I want to, instead of the slab, using opening. So the opening is exactly in this location. So one is stairs, and one is suppose we have left hand stairs. Okay, now we finished, and just we go to back to the basement base. So here is one extra floor or slab, so I'm gonna delete this one, and I deleted this one, and I'm gonna select all boundary condition or base. So I'm gonna assign it joint, strain, and a fixed. No, but a fixed boundary condition is defined. So we have now the modeling is totally completed. The next thing is let me define the loads. I can go to select here from properties. I'm going to select slab. So the slab is selected. But what I want to do is I want to go to the define, and let's see, we have two live load and dead load. So first let me apply this dead load and live load first. I'm going to assign, it is called the shell load, uniform load, and dead load is 1 point minus 1.5 kilonewton. I'm going to apply, and going to previous selection, and this is live load, and this is minus 2.5. Apply. So we finished. Okay, and now we go back to the define load pattern, and now we want to define our wind loads and also earthquake load. But let me one more thing. If I go back to previous selection, selecting this one, and I'm going to define diaphragms. This is a diaphragm. It is a rigid diaphragm. We can consider semi-rigid, the flexible, which means the contact between the connection between slabs and boundary elements is semi-rigid, so a little flexible is allowed in this type. Okay, and now I'm going to assign here called shell, and here is called diaphragm. So I'm going to apply that D. So now the flexible semi-rigid diaphragm is applied because the load for the wind will calculate it based on this point. Now we go back to the load pattern, and here I'm going to define EX, which is earthquake impacts on the X direction, seismic, and using a C716, which is the latest version of that one, and again in the Y direction. So you can the program for the combination for the design part will considering the minus and positive. So just we can define that 2 is enough. Now we want to give our properties, so we can this is X, and I'm gonna, so the structure seems the core, and the core is quite stiff and other is more flexible, ductile. So we want to consider some eccentricity. Let's suppose that eccentricity be 5% from the diaphragm, and the time period is, the first one is for steel material, steel structure, and also that can be using based on SS and SS1. And now we go to this one, the SS. Let me see again. This parameter is 1.2 and 0.6. So 1.2 and 0.6, and the long period, transmit period is 6, and the soil area is stiff soil. Another parameter calculated based on this one, and we give 4, 2.5, 4, and this is this is 2.5, and this is 4, and this is 1. So okay, and again same thing except the direction for the Y, 1.2, and this is 6, D 5, 2.5, and it's 4, 1. And now we define the earthquake, and this time we call wind. So the wind, we assume the wind is using a automatic. So we just defining one direction, one wind automatic. So the program will give us all 4 direction, leeway, windward, and also leeward. So I'm gonna call the same method, and I'm gonna, sorry, this is seismic, and I should select it to wind, modify, and you can, let me go to modify first, wind load, modify, and modify again, modify, and now go to modify natural. So here is we called exposure from the extent of diaphragms, which means the after the load calculated from the surface, and it's transferring to the center of that diaphragm. So using that method. Now here we can see this one which we applying the load, it creating about 12 direction. So you can see if you want how many you want. Let me create 2, which is one leeward and leeward, windward. So the other parameter is a 70.5, 15, and here is giving the 80 mile per hour. The exposure is B, and the ground elevation factor is 1, and the gas factor, everything we assume is okay, this one. And we don't have any parameter for the now for this modeling. We're not considering that. It's called okay. Now we define the wind load as well. So okay, and next we want to define the mass source for the equivalent lateral force method of the seismic, something called edit. So the load comes from that live load and dead load. You can consider in 25 or more. Okay, and now we can go to the load cases. We can see we have this load case. In case if you need to consider or design a model analysis to see the time period of the structure, you also can check it or modify, give more. It's at least 6 story, total 12 models can solve our problems. Okay, and this load case is finished. And one more thing, load combination. So I'm gonna call add default. So what we're gonna do is we have a steel frame design. We don't have anything else. in case it's using convert to user combination, so it's giving. After you want to edit some of them, you can, so date load -1 wind load, and you can see date load, live load, and EX. And if I go to here and EX positive, and here should be program determine -1 automatically. And you also can modify and change this, and this one, and this one, and 1.34, and 1.2, and this one is 1.211. This is based on the AAC 77, and you also can manually add this one. So now we finished. It is time to run the analysis. Now we should save the model. We can save called multi-study design. Save it. Now we can go to the analysis option. I'm going to call set the activation of 3D. Okay, and I want to go to run the analysis. So now the program is running, and it takes a while to finish. Now the analysis is completed, and here is the gravity load or deformation. So I can just delete one, and I'm going to do this one, show deformation shape. So I want to go to that case, and I'm going to considering the EX this direction. So applying some deformation contours here. If I go to the elevation, that will be much more better. So okay. So this is A, but now I'm going to 1. So let's go to here, and here is the deformation in the Y direction. You can see the top. You can put pointer here. Or we can go to the display here and story plot, and this is the first thing, date load. So we need to see the EX load. So this is the displacement from the its maximum displacement, and you can see it's about almost 20 millimeter. If you compare with the eye, so this is very least. So what we're gonna do is we want to see the drift. So maximum story drift, and you can see the maximum story drift is less than 1%. So we also can go to the shear force, story shear, and you can see the base is quite large and then distributed. And the total base shear is about minus 850 kilonewton. So you can from here consider to see the different, the negative, positive combination, everything, and stiffness, overturning moments, all these factor you can see here. So now we but the most important is that the lateral deformation, and also this is the autolateral load stories, which is the load is taking from distributed across the entire stories. So first story is least, second, and this sixth story is the largest one, which is caused a large displacement. So if you go to the maximum story displacement, so the sixth one is very large, because we have, based on this distribution, we will get the largest one here. So now this one, so this is the Y and this is the X. Next we want to consider the design. So we already defined the combination and want to check the code and defining our system. So using this code, you also have right to change another code you want, like British, Indian, or Italian, Korean, anything. So here is called the framing type. So our is called ordinary concentrically pressed frame. So using this one, and the seismic category is you can select which category. So mostly we use A, B, C, D. This OCD is allowable to this one, allowed to this 4, and I'm gonna using C. And other factor is can be as a default. You also have right to change it, and some else also you can considering the allowable deformation. This one you can change, but based on the AC7 this code, this is giving automatically. So okay, and the program will verify is it on the allowable or not. So now next we want to, so the we don't have any group. You can select the design combination. So the design combination is already giving here, and now we want to start the design. So it is actually our auto profile. We define about 20 or 30 sort of profile. So the program will recommend us a very economical one. So in the first means the analysis okay, but the section is different. So it will change it again. So after it will ask you want to iterate or not. So now it's again asking to iterate about 2-3 times. So then the program will determine the proper profile section for your structure. So it's asking again the 13 still frame is remained. So in the previous one 60, so in 30. So the last one will be finished. Again it asked me 5. Now after 5 or 7 iterations, so you will get these results. So the mostly the all profile or all beam column is passed. Now you can evaluate, see how it is worked. So we can go to here, and the exterior columns is 200 IPE, so 200, and this one, this area is first floor 220, and some other, let me rotate this one, and you can see this column is 300. So if I go to here, right click, and you can go to the detail, and you can see the calculation forms. So it take the length, stress ratio is 0.95, which is very economical, and the demand capacity and the action force come from the gravity loads, and the which is a factor which is increasing this one, and also again so finally we have this capacity, and this is the capacity load and moment capacities, moment and capacity. So this is the moment, and this is the structure capacities, the profile capacities, this one, and this is the shear force and stress ratio. So, and one more thing, and it was envelope, and this is the summary of the design. So using that LRF, so the stress ratio limit is okay. So we can go back to this one. We can go to override, and you can see you can check any combination you want, and everything is giving us. So the provision analysis method, second order, which is considered, the reduction factor, the section properties, design properties, material properties, and shear force, everything. So the design is finished, and last thing, we can go back to here and we can call verify all memory passed. It means all still memory is passed. Or let me go to show you one more thing in the browsing. So the browsing is cause a very large section. This section is very large because mostly the the earthquake load is bared by those members. Now we finished, and the next is we can create some detailing. So let me use CSI detailing. Now I can create, let me first now we want to create a detailing. So for the detailing we have three options. One is we can use CSI XCAD, a new developed plugin with AutoCAD, and also we can use CSI Revit as well. But I'm going to use CSI detailing. And now this is CSI detailing, and I'm going to create a new model here, a new one, and using that multi-story steel structure, but you have to save it, this one, before you open it in CSI. So it will take some while to extract the data. So it will reopen the ETABS and asking you, here is no concrete. So we have this data and it extracted beam column. Okay. Now here is the first floor plan, story 4, and you can see the allocation of beam column with everything. And here is also one IP section. So now we can go to some section. Let's go to section, so you can see how this section is created. We have the slab, and we have column, and we have beam. So this is just in a story 4, and we can go to an B section, and this was opening area, and it's like this. Now we can go to the other stories. Let me go to the bracing details, so I can. This is the framing section. Each story has section. This is the top and bottom. This is the base, you can see here. There was one because there is some a large loading, or because we have a core center, so this is taking a very large beam columns. If it's not in the balance, so we can change it and use a singular column like this in the entire columns. So now you can create some drawing. You can import drawing. You can let's go to the frame, and you can select individual elevation. So it's the elevation, this elevation, elevation 3, which is the bracing, and you can see how bracing is located here. And then you can import, export view to AutoCAD, and also other CAD file too. And then you can re-edit and change the size, everything. So we finished here. So this is the end of the tutorial, and the next we will go to design some connection. So we're using some connections of design software such as Idea Statica to design some of them. And we have one connection design, and one is called base plate design. So we totally have 2-3 kind of connection. We can assume using one of them and the remaining can be done by you. So this is the end of the tutorial. If you have any question, please put in the comment and I will find time to answer you. See you next time.